Hey there. Today we're going to look at some multiplication word problems. And sometimes word problems will use phrases like times as many, or times more, or times as much. And these kinds of problems are known as comparison problems. So here I have an example of a comparison problem. It says Mary attended camp for 7 days this summer. Tyler attended camp for 3 times as many days as Mary. How many days did Tyler attend camp? Well, there's a couple different ways that we can use to solve this problem. One way that I could use is I could draw a model. So I could model the amount of days that Mary went to camp, and I could use that model then to see how many days that Tyler went to camp. So for Mary, I know that she attended this amount of days, we could say, and that we know that Tyler attended 3 times as many days as Mary, so his model would be 3 times as large as Mary's. We know that Mary attended camp for 7 days, so I'm going to put 7 dots inside of my model. That represents the amount of days that Mary went. And then I'm going to repeat that down here as well, putting 7 dots inside of each of these bar models, representing the number of days that Tyler went to camp, because we know that it was 3 times as many. And now all I would need to do is count the number of days that Tyler went to camp. So he went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. He went to camp for 21 days. So that's one way that I could solve this. Another way that might be a little bit easier is by using an unknown variable equation. So I'm going to come up with a variable for the number that I'm trying to find. And the number that I'm trying to find is how many days did Tyler attend camp? So I can choose any number or any letter that I want to represent that amount. So I might choose the letter A. We'll say that A is the amount of days that Tyler attended camp. And we know that A is equal to 3 times as many days as Mary went. And we know that Mary went for 7 days. So we could say that 3 times 7 would give me the amount of days that Tyler went to camp. Again, I'm representing that with a variable, which is an unknown number. It's a number I'm trying to find in the problem. So in knowing my fact families of 3 and 7, I know that 3 times 7 is equal to 21. So I would say that Tyler attended camp for 21 days. Let's look at another example. In this example, it's a little bit different. In this example, it gives us the amount of beads that Suki uses. So Suki used 15 beads to make a bracelet. This is 3 times as many beads as what Cassidy used. So how many beads did Cassidy use? So again, they're giving us the total amount of beads that Suki has used. And we're going to solve this again using a model to start with. So I can break the total amount of beads of Susie into 3 equal groups. And I know that Cassidy only used one of those groups because Suki used 3 times as many beads as Cassidy. So if Suki used 15 beads, we're going to distribute 15 beads into even groups to find out how many beads that Cassidy used. So I would start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then when I look at just one of those models, I see that Cassidy only used 5 beads. I could also write another unknown variable equation to solve this problem. but it's going to look slightly different. In this case, we know that Cassidy used 15 beads, and we know that this is 3 times as many as Cassidy used. So Cassidy, well, we can represent with a C, since we are not sure of how many beads that she used, and we see that 3 times C equals 15. Well, I could solve this using an inverse operation or a related fact family. I know that if 3 times C equals 15, then 15 divided by 3 would also have to equal C. When I divide 15 by 3, I come up with 5. And once again, I see that Cassidy uses 5 beads to make bracelets.